Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 1 of the January daily LeetCode challenge, and we are in the first day of 2025. So big congratulations to all of you. You have done a great work in 2024 and learned a lot out of the coding. And one thing that I want to tell you is that remember, it's the consistency which matters in case of coding, because the things that we're learning now in each of these questions, you should be able to carry them forward and use them when the right time comes. Okay, when the right problem comes, you should be able to apply them and show them that yeah, you have learned something. But if you are not consistent in this, I am damn sure that whatever you're learning now, a time will come when you will not be able to reproduce the same thing. Okay, in terms of program I'm saying. Okay, so that is why it always matters that if you learn something new, I'll keep applying and keep solving something. Okay, remember that it's not only about clearing interviews. Even in your job, you will face some scenarios where these coding things will be helping you a lot. Okay, remember, you will not get problems like this, okay, the way we are getting it now. But yeah, you will have to think of the problems yourself. For example, in case of a SQL server, you can think of like you can think of the case of a graph. For example, let us say we are generating the code for a views. Okay, all the views we have in the SQL server. So in order to ensure that each of the views are created in such a way that no one it depends on another. Okay, something like that. That is, so if you way view B is dependent on a view A, then view B should be created after view A is created. Okay, something like that. So those dependencies and all, you can think of a graph and you can implement it. Okay, that's what I'm just trying to help give you insight that yeah, these things will be useful in even in your programming, the work that you're going to do in your office or job. Okay, that's why these things are important. They will play a very important role in getting into the company. At the same time, even in your tenure during the company, you will be able to produce some good results if you are knowing these things. So with this, I want to start the first day of 2025. And yeah, coming to today's question, it's an easy one to begin with. It's question 1422, maximum score after splitting a string. So let us quickly see this question. I will show you three approaches today. Okay, and then I will discuss the both Python and Java solutions for this. So total four approaches I am going to show you. Out of them, one is going to be Java. So let us see this question now. As you can see, it's a very simple question. The input is going to be a binary string. Binary means it is going to be filled with zeros and ones. Okay, and the output is has to be a integer. Now let us see here the maximum score after splitting a string. So given a string s of zeros and ones, return the maximum score after splitting the string into two non-empty substrings, that is the left substring and the right substring. Okay, the idea here is this particular string that we are given, you have to split them into two. Okay, and one they are calling it the left substring, the other one they are calling the right substring. And one thing that you have to remember is that they have to be non-empty. That is, one of the substrings cannot be empty in that. Okay, both have to be at least both should contain at least one element. The score after splitting a string is the number of zeros in the left substring plus the number of ones in the right substring. So if you see the example one, they have done a very good job in explaining you the whole situation here. So if you see, they are showing you multiple ways of splitting the string, and in each of this case, what is the score that is coming? Okay, let's see the first one. So if they are splitting it like this, that is, they're keeping only 1 0 here, and the rest of the digits are in the right substring. Okay, so what is the score coming? Score will be always equal to number of zeros in the left substring plus number of ones in the right substring. Okay, so here only there is single zero in the left substring, so score will be 1 plus number of ones in the right substring. What is the number of ones in the right substring? It is 4. So 1 plus 4 is 5. Okay, and let us see one more example also. Here if you see, it is 0 1 and the right substring has, see, this is the left substring now, and the right substring like this. Okay, 1 1 0 1. So in this case, if you see the score is going to be number of zeros in the left substring, which is going to be 1, and the number of ones in the right substring, which is going to be 3. So 1 plus 3, which is 4. Okay, so in this way you have to keep checking all the cases. Okay, after checking all of them, whichever returns the highest score, for example this case returns the highest score. Okay, so this is the left substring for us, and this is the most optimal right substring for us. Okay, so this returns the highest score, so this is going to be the answer. You have to return the highest score is the answer. Okay, you can go to the example 2 also. It's almost similar to that. Okay, and if you see the constraints, since it's a very small question, it is going to up to 500 only. Okay, and since it's a binary string, the characters are going to 0 and 1s only. Okay, now how to do this question? See, there are multiple ways to it. You can even think of a brute force approach. There are multiple ways to it. Like, that's why I'm saying it's not only about this. I will show you three approaches total, but yeah, you can even think of some force way of doing it. Okay, that's what I'm just helping you. See, please do not remit yourself onto the optimal thinking, optimal approaches. Try to do from the scratch, then keep building forward. Okay, remember, even once you do the optimal approach, still those optimizations that you will need to include, right? Those thinking will only come only if you have solved the brute force way. Okay, remember that part. Only if you know the question in depth, only then you will be able to apply some of the optimizations which we have previously seen, right? For example, in case of DP, we have previously seen that those optimizations, that will only come to your mind if you are very much deep into the question. That is, you are very much deep into the brute force solution. Only then you will get to know that okay, where we can optimize further. Especially in the case of DP, this becomes very very important, because in graphs you can say like, yeah, if the algorithm is optimal, the solution will be optimal. But in case of DP, it's not like that. Every small optimization you have to keep including them, only then it will be optimal solution. Simply by saying I'm including a DP solution where I'm caching the results, those things will not work. Okay, if you have to optimize further, it has to be everything will have to think and you have to include. Okay, that's what I'm trying to say you. That's what we have seen in the previous year's questions in DP. Okay, in 2024, the last few questions we have seen that. So coming to this question, okay, the first approach that I'm trying to show you is that here we will be having both space and time complexity often. Okay, so what we are going to do, see, first of all, I'm going to cache the results. What I'm trying to tell you is that, see here, you can think of it like a prefix sum way. Okay, here what I'm creating array called zero set left, and similarly I'm creating array called one set right. Okay, all of them will be having zeros initially. Yeah, and we can see the length also. My n minus 1 I'm kept here because remember here it has to be non-empty strings, right? So the idea here is we cannot, the left substring cannot be bigger than this. Okay, just see here this part, the left substring cannot be bigger than this. Okay, that is always one character has to be left out in order to ensure that none of the strings are empty. Okay, simple as that. For that reason I only need the results for m-1. Okay, yeah, first m-1 letters. Now first of all I will show you how it works. I will just populate the results and I will show you. See, the left means that I'm talking about this. Okay, the zero set left and the one set right. What it means that if you see the code here, so the first output is for zero set left. Okay, this part is the zero set left. So what it will tell you is that, for example, let us say I am at this particular index. So including this index and towards the left, how many zeros are there? It will tell you the count for that. Okay. Remember, including the current index, how many zeros are there towards the left. Okay. Similarly, if you come to this part, it will tell you including this index, how many zeros are there towards the left. Okay. So remember, the answer will be only for these many characters. Okay. If you see here, the answer, the length here is 5. Here also it is 5. I am not calculating the result for this particular index. Remember that part. So if you see, the length of this is going to be 1 minus than the length of this. Okay, remember that part always. So if you see for this particular index, the answer is coming to, because including this there are two zeros towards the left. Okay, now but the case of right is slightly different here. The case of right is slightly different. I will tell you how it is different. In right, what we are doing is excluding the current index, how many zeros are there towards the right. Okay, for example, if you see, yeah, see the case of this particular, yeah, in the right case, obviously we are only considering this particular part. Okay, so if I talk about this particular index, okay, yeah, this particular index, if I talk about here, remember one is not there, but towards the right there is only one. Okay, for that reason it is populated as one. Okay, similarly if you talk about this case here, towards its right there is only one. Okay, so that's what is being populated here. Okay, now if you talk about this particular thumb, there are two ones towards its right. Remember, the current index I'm not including. Excluding the current index, there are two ones towards its right. Okay, that's why two will be populated here. Similarly this case, you know yeah, yeah, this part, there are three ones towards the right, and so on. Like, that's what is being populated here. Okay, that's what I'm trying to show you. And yeah, if you talk about the last one, there are four ones towards its right. Okay, that's why here it is being populated as 4. And yeah, if you talk about this part, there are three ones towards its right, excluding the current index. So here is 3. That's what it is. So see, the reason why they are like slightly different is, see, in case of zeros we are including the current index also, but in case of ones we are not including the current index. Okay, because that is the requirement of the question. Okay, because the current index has to be among one of them, so we are including them in the case of zeros, but we're not including them in the case of ones. And then we are like populating them. So if you see how I'm populating them, see here, I'm just going through each of the elements. Then if they are 0, I'm just first of all making this element as 1. That is the index for zeros at left. I'm for this particular index, I'm populating the value 1. And then if it is not the 0th index, I'm including the value towards the left also. Okay? That is just like a prefix sum. You can think of it just like a prefix sum way. That's what we are doing it. So whatever was the value towards the left, okay, that is I minus 1 index. I am taking that value and adding it to the current value. See here, already this has a value 1, and again I'm adding the value which was there towards its previous index. Okay, the value in its previous index in zero set left array. Okay, what was the value that I'm taking and populating here? Why I'm not taking 0 is that because for 0 there won't be any element towards the left. Okay, so this will give me minus 1. For that reason I'm excluding the 0, right? Then I'm printing this part, and then I'm calculating the count of ones. So how I'm doing that, see here, if remember s of minus 1 means the last element, right? The last element here. Okay, so if the last element is 1, count of ones will be 1. Okay, as simple as that. Next, what I'm doing, I'm starting from right towards the left. I'm starting from the n minus 2 index. I'm going till the index 0 in the reverse way. Okay, in the reverse way. So what I'm doing, first of all, whatever is your count populated here, okay, you have to populate it here first, and then you have to check that if the current index is 1, then make it increment it by 1. Okay, the idea here is the current index count should not be included. That is the current index. If it is 1, we should not count it and include it. Okay, we should include it in the next iteration. Okay, that's what we are trying to tell you. Whatever is the count we populated here. Okay, but if the current index is also 1, then we will populate in the next index. Okay, as simple as that. Next index towards the left. Okay, as simple as that. Then if you see what we are doing, then this is the most simple part. What we are doing is that we are going through each index, and then we are checking whether at each particular index, if the number of zeros towards left, including the current index, and the number of ones towards right, if I'm just adding them and just comparing to the previous max. Okay, so whichever is the max, we'll store it here and finally we return it. So let me go run this and show you. If you can see, this is how it works. So idea here is at each step we'll be adding this part and this part. Okay, similarly this part and this part and so on. So at each index we'll be adding how many zeros are that towards the left, including the index, and how many ones are that towards the right for the same index. If that count is a bigger one, we are going on updating here, and then we return the answer. So if you see the space and time complexity, here we are having two arrays. Okay, so it is O of n solution, but remember here we are having two arrays. Okay, both of them are having a space of n. Okay, and if you talk about the time complexity, again this part is going to take O of n time, this part is going to take O of n time, and this part is again going to take O of n time. So two arrays and three loops through the whole array. Okay, remember that part. Now coming to the next solution, what we are doing in the next solution, if you see if you see here, we are having two arrays. So now we are trying to optimize that. We are trying to reduce one of the array. Okay, here if you see, I am not having the left array. Okay, if you see this particular array, a zero set left, this array I am not having it. Okay, so the idea here is, while doing the last calculation itself, because since I'm going through all the arrays from left to right, I can calculate how many zeros we have witnessed seen till now. Okay, so that is the basic idea. Now I'm going to eliminate this part. Zero set left, I'm going to eliminate now. Okay, so if you see here, there is no zero set left, I'm only having one set right. Okay, so this is exactly same what we have done previously, the same part here. So the idea here is this whole thing. Okay, this whole array, zero set left array, and the whole calculation for that array, we have now omitted. Okay, so yeah, if you see now what we are doing in the in the final loop, what we are taking in the final loop itself, we are, whenever we are seeing a zero, we are calculating the count of zeros. See here, we are maintaining a variable called count of zeros, which is zero initially, and then whenever we are seeing a zero value, we are incrementing this count. Okay, count of zeros is equal to count of zeros plus one, and then we are doing this part. Okay, the count of zeros plus ones at right. So idea here is, we are only caching the number of ones at right for the each of the indexes, but for the zeros we are calculating them as and when we progress to the array. Okay, so here what we did, here everything was cached, even the zeros towards the left and the ones towards the, everything was cached. But here what we are doing, here only the ones are cached. Zeros we are calculating them as and when we are progressing to the indexes. Okay, as simple as that. So this also is O of n solution. Both space and time complexity are O of n. But if you see what is happening here, we are having only one array here, and if you see how many times we are going through the loops, for this thing we are going through one loop. Okay, that is, we are going through each of the elements once, and here again we are going through each of the element once. Only two times we are going here. In the previous calculation, you have seen that we are going three times. Okay, this is the first time, this is the second time, and this is the third time. So we are going through the array three times. But here what we have optimized is, we have removed one of the array, and we are going through the loop only two times. Okay, for calculating the this particular array, once at right we are going through once. Okay, in each of them, and again we are going when we are doing the final calculation. So two times we are going through each of the elements, and we're having only one array. So again, it's open solution in terms of space and time complexity. One more optimization that we can think of is, see here, instead of maintaining that, okay, that is the idea here is, now we are targeting how to reduce the space complexity further. Currently the space complexity is O of n. Okay, instead of this O of n solution, now we want O of one solution. Okay, now our aim is to get a O of one solution. The next we will trying to do that. Okay, now if you see here, we are just in the starting itself, we are just counting how many ones are there. Okay, this I'm showing at count of ones. Okay, this time if you see, there are no arrays, so it's going to be O of one solution. So the idea here is, here we are going to count how many ones are there, and if the current element is not a one, or if it is a one, then we are going to predict the how many ones are there towards the right based on this particular value. Okay, see how we are doing that. So this count of ones is going to tell me how many ones are there in the whole string. Okay, and answer is initialized with zero, count of zero is initialized with zero. Okay, what we are doing next, we are going through each of the elements. Okay, we are going to each of the elements. If the current element is a zero, populate the count of zeros. If the current element is a one, what we have to do, see, remember, we always want how many ones are there towards the right. Okay, excluding the current one. Remember, please be very clear with what the ideology that we are following. Remember, for zeros we want how many zeros are there towards the left, including the current index. But for ones, we want how many ones are there towards the right, excluding the current index. Okay, always this will be the ideology that I'm following. Okay, in all the three approaches. So if you see, count of ones is going to tell me how many ones are there overall, that is in the whole array. So if the current index is a one, so but I don't want to include the current index, remember that yet. So I only want, apart from the current index, how many ones are there towards the right. For that reason, if the current index is a one, I'm going to subtract count of ones by a one. Okay, as simple as that. And then I'm going to do the calculation, that is till now how many zeros we have seen and how many ones are going to be there towards the right. If I am adding both of them, like whatever answer I'm getting, I'm comparing them with the previous max. If I'm getting a new max, I'm getting storing it in the answer, and then I'm returning it. So let me quickly run this also and show you. As you can see, this is also clearing most of the test cases, and this is O of 1 space complexity, O of n time complexity. If you talk about how many arrays are there are no arrays here. Remember, that's why it's O of 1 space complexity. And how many loops we are doing, that is how many times we are going through each of the elements. See here, maybe for this we are going through once, that is for each element we are going through once because of this, and other part is this, we are going through each element one more time. So throughout the whole program, only 2 times we are going through the array. Okay, only 2 times we are going through each element of the array. Okay, one is for calculating this part and the other is for calculating this part. Okay, so the second solution that I've shown you, I am going to show the Java solution for this now. So this is the Java solution for this. Okay, so if you can see here, yeah, if you, this is going to open and open. Okay, both space and time are going to open. Okay, for this particular solution, if you want the Java solution, I am expecting you to code it because see, I've been giving the Java solution for the second approach that I've shown you. Okay, where we are having open and open space and time complexity. Okay, I want you to code the Java solution for this and paste it in the comment section. If you are having any doubts, please do reach out. I can help you in that. Okay. But for now, I'm showing the Java solution for the second approach. Okay. So let me show you what we are doing it here. We are taking the length. Okay. Then we are creating array called one set, right? And the elements, and then this is going to be n minus 1 elements. And then again, we are initializing a value called count of ones. Then if the current that is the last element, remember the last one, if it is a 1, increment it by 1, then we are going through each element in a reverse way. We are starting from n minus 2 and we are going till 0 in a reverse way. Okay, whatever is the value till now, mark it here, and then if the current element is a 1, that is index I is a 1, increment it. Okay, and take it forward to the next value. Okay, that's a I minus 1 value. Okay, as simple as that. That idea is very simple. What, see, current index, we are not, if it is a 1 or 0, that we are not bothered. Okay, so how many ones are that was right, only that we are going to store in the ith index. Okay, so that's why if you see, first we are marking the whatever we are having the count of ones, we are first storing it here. Okay, we are caching it here, and then we are checking if the current index is a 1, then we are incrementing it to be written for the next iteration. Okay, that is to be written in the I minus 1 value. Okay, to be cached with I minus 1 index. Okay, as simple as that. Now I'm initializing the answer, I'm initializing the count of zeros, then I'm going through each array, that is going through each element, and then if the current element is a 0, count of 0 is equal to count of 0 plus 1, and then I'm calculating the max. Okay, count of zeros we have seen till now, comma, plus count of ones at right, that's from the current index, how many ones are that was the right, I'm getting that using this particular cached array. Okay, I'm using this particular array to get the cached results, and then finally I'm returning the answer. So let me quickly run this and show you. So this solution, like if when I ran it, it ran it in 0 milliseconds. Okay, this was around 90, it is beating 97% of the test cases. So yep, this was the alternative for this particular solution. For this particular solution, which is O of 1 space complexity, I am expecting you to do the Java solution and write it in the comment section. And if you're having any doubts, please do let me know, I can paste the same for you. Okay, so often that was all for today. We saw 3 approaches, and we also saw the Java solution for them. Okay, the optimal approach here is O of 1 space complexity and O of 1 time complexity. So yeah, and that was all for this particular video. I hope you like my content. Please be consistent in your approaches. Remember that I always emphasize this because this is the day one. You always will see this is a new start. Sometimes what happens is people will discontinue in middle of the month, and that's why they will not continue further because they know that okay, I have discontinued. So if you see my continuity, I have solved from the last 71 days continuously. So yep, I'm just trying to motivate you that please complete the challenge. Don't leave it in between. Today is the first day of the January Daily Code Challenge. Please pay attention. You are definitely learning something new, and whatever you're learning new, you will have to utilize them. It's not like it's something a challenging thing that we are doing it. The only thing that you have to do is you have to solve every day. Okay, there is no alternative for that until and unless you reach a place where you are thorough and you are definitely confirmed that you don't need this anymore. That is, you don't have to crack any more interviews. When you are in such a stage, yeah, you can leave it, but till then you will have to keep doing it. So often that was all for this video. If you like my content, please subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.